All right, so in the previous video, we looked at Venn diagrams as a way to kind of visualize the principle of exclusion, inclusion. Exclusion, inclusion. So now let's take a look at a couple of examples here. So let's start off with something that is with two sets here. So for example here, let's say how many 7-bit strings of weight 4 start with 1 1 or end with 0 0. All right, again, let's let A be the set that they start with 1 1 and B be the set they start, or excuse me, end with 0 0. Notice this is much different than the one we did in the previous problem where it was starting with 0 0 or starting with 1 1, right? We're looking at the ends of these bit strings here. So let's try to figure out the cardinality of each one of these sets, right? So again here, A, B. A is going to be the 1 1, and then B ends in 0 0. Okay, so now the cardinality of A, right? So they are 7-bit strings. 1, 2, 3, 4, 5, 6, 7, and they start with 1 1. All right, so these are of weight 4. So meaning in the remaining spots, I have 2 more 1s to work with. So 5 choose 2 is the operation. And calculating that, we see that that is 10. All right. Now for the cardinality of B, 7, here we have 0 0 at the end. Right? That means we have 5. Still 5 places. Now here we have 4 ones to play with. So this one would be 5 choose 4. Right? And that we can do, calculating this, that'll be 5 different ways. All right. So now we need one last thing here. What does the cardinality of the intersection look like? All right, that's my overcount, right? Which ones had the property that they started with 1 1 and ended with 0 0? All right, so now this one here, we had, not 5 here, we have 3 more positions to play with, and there we have 2 1s to work with here. So 3 choose 2. Turns out that that is 3. All right, so now we want to find A union of B. The cardinality of that, that's the cardinality of A plus the cardinality of B minus the cardinality of A intersection B. So that gives me a total of 10 plus 5 minus 3, which is 12. All right. Again, we have to make sure that we are appropriately counting, right, so that we get all of the possibilities here. So that's one using 2 sets. Let's take a look at one that uses 3. All right, as a reminder here for A union B union C for the principle of inclusion, exclusion. Right, we have the magnitude of A plus the magnitude of B plus the magnitude of C, and then we subtract off all of the pairwise intersections. All right, but that is a step too far, and we add back in the intersection of all 3. Okay, so for this example, let's say I want to find out how many of the numbers one, two, all the way up to 50 are multiples of 2, 3, or 5. Okay, so let's appropriately define these sets here, right? So let's A be a multiple of 2. And let B be the set that is a multiple of 3. And then C be a set that's a multiple of 5. Okay. So, as it turns out, right, the cardinality of A, those are all the even numbers. So there are 25 even in that set. The cardinality of B, right, those are all the multiples of 3. So like 3, 6, 9, etc., 12. There's a total of 10 there. And lastly, the multiples of 5, right, 5, 10, 15. So that is 10 of those. All right, and now let's take a look at the intersection of these pairwise. A intersection of B, multiple of 2 and multiple of 3. So this one is, we're looking at actually all the multiples of 6, right? So we can divide those by 2 or 3, or there are a multiple of 2 or 3. So like 6, 12, 18, 24, etc. As you can see, those have a multiple of 2 or 3. Excuse me. 2 and 3, all right? Careful, right? Careful. That is 8 of them, all right? And now A intersection of C, multiples of 2 and 5, right? Or 10, so that's 10, 20, 30, 40, 50, so there are 5 of those. And then B intersection with C. Right, that is a multiple of 5 or 3, so those are by 15, so 15, 30, 45, so there are 3 of those. All right, and then lastly, the one that is in the intersection of all of these. There's only one of those, namely 30 is a multiple of 2, 3, and 5, so, okay. There's only one in the numbers between 1 and 50. All right, so now let's calculate the union, right? So A union B union C. So we add B is 16, not 10. Okay, so I'll add the card A, B, and C. So this is A. Actually, let me just write these down here. So we'll add 25 plus 16 plus 10. All right, and then we'll subtract off all of the pairwise intersections, and then that went a little too far, so we add in the intersection of all 3. And this gives me a total of, here, let's see, quick calculation here, 35, 45, 51, minus 16 plus 1, so that's 52, 16, equals 33. All right, 30. 36, excuse me. All right, so 36 numbers are a multiple of 2 or 3 or 5. All right, and that's how we apply the principle of inclusion exclusion when we have 3 non-disjoint sets.